Hi everyone, today we are going to present about crystal structure.
Hi, my name is Zarif Hanan binti Zulkafli.
My name is Muhammad Haziq Aiman bin Ismail.
My name is Nur Aina Shahida binti Ahmad.
Hi, my name is Arba'i binti Ahmad Faizil.
Crystal structure is to consider atom as being hard sphere with a well-defined radii and consider as crystalline structure as a lattice point at atom. In this hard sphere model, the shortest distance between two like atoms is 1 diameter.
Here is common material with various viewpoints, which is ceramic, glass, graphite, crystal, metals, and the last one is poly.
I will continue the presentation with the definition of crystal and 4 basis type of crystal unit cell under the topic body-centered cubic (BCC). What is the crystal? Crystal is the product of lattice plus motif or basis, typically an atom or a group of atoms associated with each lattice point. Lattice, the underlying periodicity of the crystal, while basis is the entity associated with each lattice point. Lattice, translationally periodic arrangement of points, while the crystal is translationally periodic arrangement of motifs. Let's take a look on an example of crystal. Basis plus lattice equal to crystal.
Now, I'll explain about the space lattice and unit cell. Firstly, the crystal structure is an atom that arranged in repetitive 3D patterns in long-range order. Next, the properties of solids depends on the crystal structure and bonding force. Space lattice is an imaginary network of lines that represent the arrangement of atoms. Next is the unit cell. It is a block of atoms that repeat itself to form space lattice. And the last one is amorphous material, where the material is arranged in short-range order. Now it's about the unit cell. It is the smallest structural unit or building block that can describe the crystal structure. Repetition of the unit cell will generate the entire crystal. Here is a two example of 2D honeycomb and 3D crystalline structure. For the crystal systems and Bravas lattice, there are only 7 different types of unit cells that are necessary to create all-point lattice. There are 40 standard unit cells that can describe all possible lattice networks. Lastly, there are 4 basic types of unit cells, which is simple, body-centered, face-centered, and base-centered. There are 7 types of unit cells. The first one is cubic, where A is equal to B and equal to C. The second one is tetragonal, where A is equal to B but not equal to C. The third one is orthorhombic, where A is unequal to B and C. And the next one is rhombohedral, where A is equal to B and C. The fifth one is hexagonal, where A is equal to B but unequal to C. And for monoclinic and triclinic, they are just the same, where A is unequal to B and also unequal to C.
Body-centered cubic units atom at each of the 8 corners of a cube plus 1 atom in the center of the cube. Each of the corner atoms is the corner of another cube, so the corner atoms are shared among 8 unit cells. It is said to have a coordination number of 8. The BCC unit cell consists of a net total of 2 atoms, 1 in the center and 8 from corners atoms as shown in the image below. The BCC arrangement does not allow the atoms to pack together as closely as the FCC or HCP arrangement. The BCC structure is often the high-temperature forms of metals that are close packed at lower temperature. The volume of atoms in a cell per total volume of a cell is called the packing factor. The BCC unit cell has a packing factor of 0.68. Example of material that have BCC structure: lithium, sodium, potassium, chromium. This is the formula and calculation for atomic packing factor of BCC structure. By using this calculation, we can show that the APF of BCC structure is 0.68.
Next is face center cubic structure, FCC. Face center cubic FCC structure is represented as one atom each at the corner of the cube and at the center of each cube face. In addition, the coordination number for FCC structure is 12. Thirdly, the FCC unit cell consists of net total of 4 atoms. Lastly, atoms contact each other across a cubic face diagonal. This is formula for lattice constant A equals to 4R divided by square root of 2 and square root of 2A equals to 4R. This is formula and calculation APF of FCC structure. As we know, unit cell contain of 4 atoms per unit cell. APF is equal to atoms per unit cell times volume per atom divided by volume per unit cell.
HCP crystal structure. The HCP structure is represented as an atom at each of 12 corners of an hexagonal prism. Atoms attain higher APF by attaining HCP structure than simple hexagonal structure. The coordination number is 12, so the APF of HCP is equal to 0.74. The HCP structure has 3 layers of atoms. In each the top and bottom layer, there are 6 atoms that arrange themselves in the shape of hexagon. There are 2 lattice parameters in HCP, which is A and C. It's representing the basal and height parameter respectively. Therefore, its HCP unit cell has 6 atoms. Here is the example for zinc and cobalt. Ideal ratio for HCP is 1.633. First type is 3D projection. The top layer and bottom layer we call it A side and the middle is B side. Next, we look at for 2D projection. It also have 3 layers which is top, middle and bottom. Here is the example of calculation APF for HCP. So, we can use this formula to get the APF value.